Hello everyone. This is the second last video of this paper. And today we will be going through from question 16 to 20. Let us get right into it. This was our last question for the previous video. Starting off today, we have been greeted with very easy questions. For this, we are going to take the HCF value and take common. By putting brackets, we are finalizing the factorize. And this is the final factorize. For the second one here, we have a quadratic equation. To factorize this quadratic equation, we will have to do middle term. After taking common, we rewrite the parenthesis as the final factorize. On to the next one. We are presented with a diagram. We are given that each of his sphere inside the cuboid have a diameter of 8 centimeters. So logically, their radius will be 4 centimeters. We are told to calculate the space that is not occupied by the spheres inside the cuboid. So we will find the volume of the cuboid, and then subtract the total volume of all 6 spheres inside the cuboid. All the lengths of the cuboid are given, so we can multiply and find the volume. Now since we know the radius, we can find the volume of the spheres too. Formula for the volume of a sphere is 4 over 3 multiplied with pi and the radius cubed. And for this question it's 4. Now we have got the volume of one sphere. So by multiplying with 6 we get the total volume. Now we can subtract the values from each other and we will get our answer. Also, since we have been asked to provide the answer in 3 significant figure, we will have to do that. And it will become 1,460 centimeters cubed. For this next one, we have here is a histogram table and a graph to represent its values. We are asked to fill in the blanks of the table and also draw the incomplete graph properly. After taking a quick look, the common value that is drawn in the graph is the third row. By using this formula, we can find the frequency density and then draw the rest of the graph. For the third row, we see the range is about 60. The frequency is given 180. Using this formula above, we can find the scale of frequency density. And we get 3. And we label the 3 level with the third bar. If you notice, 3 is exactly above 3 blocks. This indicates each block is an increase of 1 in density. We are going to label until the topmost within our necessary coverage. Since we can see the range of 60 is varied by 2 blocks, it is common sense that each block represents 30. Now we will go ahead and label the minutes at each block. So from the graph and the table, we will find the blank values. After that, we will complete the graph. For the graph, we need to calculate their respective frequency density, using the same formula. It's 2, so 2 up and 2 to the right. For the other one, the range has doubled while the frequency remained the same. By doing the division we get 1, and that we will draw to finish this question. We have a final part for this one, a sum of probability. We have been asked to find probability for over 120 minutes. The last 2 rows are giving frequency with time of over 120 minutes, which adds up to 240 out of 900. We will write 240 over 900, put that into our calculators and find the simplified fraction. And we get 4 by 15. We will write down the proportional relation we are given among the variables. F is directly proportional to g squared, and g is inversely proportional to h. To remove proportionality, we will add 2 different constants, k for f's equation and c for g's equation. Now we will switch the values with the variables given to us in the question above. This will let us manipulate the equations and find the values of our constants. Now we reconstruct our equation, replacing the variables of the constants with their values. Here, we can start by putting the equation of g into the equation of f, then simplify it to get our desired answer. And we get this equation of 144 over h squared as our answer. For the last one today, we have here a question from Bound. We are asked to find the lower bound of the height of the cylinder. We will have to change the formula of density to isolate the height from the whole volume of the cylinder by replacing it with its formula. Now we reciprocate the positions of h to the left all alone. Before starting to switch the variables with values, we will write down the required bounds of our values. Since the bound for mass is to the nearest 10, we will add and minus with 5. After that, we will take the lower bound as we want the numerator to be smallest possible. Same for the radius. We will add and minus with 0.25, as it is said to be nearest 0.5. Then we will take the upper bound to keep the denominator biggest possible. Repeat with density 2. It is nearest point 1, so we will add and minus with .05, and then take its upper bound. Now we will switch the bounded values. Pi is said to be considered 3.142s. We will make sure to do that. Then just place everything in position and put everything in our calculator to get our simplified final answer. And we are asked to answer in 1 decimal place, so do not forget to do that. So we are done with today's paper. The next video will conclude this paper with all the remaining 6 questions. It will be uploaded soon as work for it is in progress. Hopefully it will be available within this week. I hope your problems were solved. Don't forget to like the video, subscribe to the channel, and share the video to your mates. Make sure to comment regarding any questions and I will try to answer it. Thanks for watching.